So hello everyone. So I'll solve a quick problem and on column design, and also I'll show few more slides on the column design. So what this slide shows, these are the in the column typical column design with uh, different situations. If there are four bars are used, four longitudinal bars are used, then uh, this is the design. If it is four longitudinal bar is used, then it's like two ties. This is one tie, this is two tie, for 8 bar is two tie, and for 12 bar is three tie, and if it is 16 bar, this is the combination. So I can just draw it again. If it is four bars, four longitudinal bars, those are the four bars in four corners and just one tie. So this is like one tie. This is the one tie. And if there are 8 bars, then you need to put four bars in four corners and then put another four bars in the middle, and then you need to connect this, and one tie is the regular tie all around, and then you need to put another tie connecting those two four middle bars. So therefore it's total 8 bars and two tie. What are the two ties? This is tie number 1 and the other tie is this new one. So total 8 bars and two tie. And if it is total 12 bars required, so then we need to put the, then we need to set total 12 bars. So then first I do the first tie. So you can put the first four bars, and then we can put two bars in the middle of each of them. You can do multiple ways. You can also put a tie connecting this end once, depending on how much you need. But one of the way is to do connecting. There's a tie bar all around this, and there's a third tie bar all around that. So this is tie bar number 2, tie number 2, and this is tie number 3. So total 3 tie bars. This is one of the typical, but as I said, you can also put arrange tie in a different way as well. So if it is 4 bar, 1 tie, 8 bar, usually 2 tie, and 12 bar, 3 tie, and then it's ongoing. And this is the difference between hook angle. One is 90-degree hook angle, and this is 135-degree hook angle for the tie bar. Hook angle in the tie bar. So if you see this, this is the 90-degree angle. If you put the tie like that, they will overlap like this 90-degree angle, then it's called 90-degree angle. And if it is like that, then it's 135-degree. So I'm drawing the 90-degree one. You can put the tie bar like this, then it's 90-degree. And if you putting the four arms first, and if you put like that, then it's 135-degree. So you can put 135-degree angle or 90-degree angle hook in the tie bar. And this figure shows the minimum spacing and maximum spacing. So maximum spacing between two longitudinal bars is 500 millimeter and minimum spacing is 150 millimeters. So if I just draw a simple column cross section, So if I just draw, so 8 column, 8 river. So then the distance, clear distance from bar end to the bar end to the bar end is, there's a minimum and maximum to the end, to the end, to the end. So there's a minimum and then there's a maximum. So the maximum, this spacing should be more than 150 millimeter. This spacing should be more than 150 millimeter and should be less than 500 millimeter. So maximum is 500 millimeter spacing and minimum is 150 millimeter. Spacing between two long bars. Spacing between two long bars. Okay, so there is lots of rules, so you need to follow and check each of them in the design problem. For example, this is the minimum number of rivers, as I earlier showed, I told many times. For tie bar, rectangular tie bar, there's minimum 4 bars. And then for a spiral, which is usually circular, 6 bars minimum. This is minimum and minimum. So tie bar, rectangular, minimum 4 bars, spiral, circular, minimum 6 bars. And minimum bar spacing. So this minimum bar spacing for column should not be less than the greatest of. So you need to take the maximum of this three number, 1.4 diameter multiply bar diameter, 1.4 maximum aggregate size, and 30. You need to take the maximum, and it should not be less than. Should not be less than. So that means it will be more than that. And this is the minimum bar spacing. And maximum bar spacing. Maximum bar spacing should not be more than 500 millimeter. So this is the spacing max. Max is 500 millimeter. And then the tie bar size, tie size, and tie spacing. And it was also showing the clause number in the concrete handbook. So tie spacing should be minimum 10 number and should be at least 30% of the largest longitudinal bar size. So if it is a 30 M bar, it should be at least 10 M tie. If you use the 30 M bar, we need to use at least 10 M bar. And the other one is we should all usually use 10 M tie size. And also the tie spacing, so it should be less than this. So you need to take the minimum of these 4. You need to take the minimum of these 4 numbers and should not exceed this. So it should be less than that. So our tie spacing should be less than this 4. We need to calculate all 4 and then whatever the minimum value, and the tie spacing should be minimum of this 4. And this slide shows the spiral column rules, the steel ratio, spiral column, and steel ratio, spiral column, steel ratio. So you need to use this equation. dv is the spiral bar diameter. ASP equals to pi dv square by 4. Pi dv square by 4. So this guy goes to here. And LSP goes the next. LSP is the pi dc. LSP equals to pi multiplied dc. And what is dc? Dc is the outside diameter of the concrete core. and AC is the pi DC square by 4, and P is the pitch. P is the pitch, the distance between successive spiral turns. Like as I said, this is the spiral, so the successive distance between two spiral turns, the distance between, that is the pitch. Okay, so this is the steel reinforcement calculation for a spiral column and for a steel ratio. And I wanted to show this bar size, the bar size diameters. So we need to use this diameter values, bar dia values. So always use this actual bar diameter, and this is the area. So we need to use in the column, and in all the whole design course you need to know all this area of bars. So we need to use all the bar area and also the bar diameter for each of the bar sizes. And in the book there is a summary given. It just if you don't want to multiply, if this table just shows like 4 bars. If you use 4 bars of 30 m size, so it should be just 4m 30 multiply 4 30m bars, so 4 multiply 700, so it's 2800. So this one, for example, this is 4 multiply 700. If I test another one, say 24 bar of 25m. So 25m is 500 bar, 500 millimeter square. So it should be 25m is 500 millimeter square divided by 24. So it's 12,000 millimeter square. And this is millimeter square. So it's like we are getting this from this table, and in the book it just did the multiplication, so you can just use the original table in the first place. So I'm going to solve this problem quickly. I'll go through super quick. One, there are some assumptions in this problem, that this is short column. In the other video I showed that we're doing short column, not long column or slender column. Other one is it's a tight column, and also it is a square cross section. So 3 things are given. And another assumption in this problem is like manual interaction diagram was not drawn, but you need to practice drawing interaction diagram for your exam and for your assignment and exam. So in this particular problem, interaction diagram, it does not need to be drawn, but in other problems you need to practice drawing the interaction diagram manually, of course by ASCII software, but also manually. But in this particular problem we are not drawing it, but other than that we are designing this column. And also it's given the force and the E eccentricity, and clear cover is 40 millimeters. Yeah, clear cover 40 millimeters. So for that, first what we did, we calculated the estimate the column size. And how we did that, we did divide PF, the axial force, divided by 0.5 FRMC. So PF is 1500 kilonewton, and 0.5 and multiply FRMC, we get 120,000. So then, since it is a square column, so it's like B square, so B equals to root AG. So then we get 346. We can round it number 350, but then we need to always make it upper bound, and we should always use 50 millimeter increment. 50 millimeter increment. We cannot have 4 millimeter increment, so we need to always have 50 millimeter increment at least. So that's why we are going upper round number, making it 400 millimeter. So then when we get 400, so it's just 400 square and 116,000. Now steel ratio for column, steel ratio should be between 1% to 4%, 1% to 4%. I saw that in the midterm exam, a lot of you forgot to put percentage sign or put it in this format. It's either 1% to 4% equals to, or without percent sign it is 0.01 to 0.04. So for this problem we are assuming, trying to keep it still low, so we are assuming rho equals to 1%, which is 0.01. So then we can calculate the still area. The still area is rho t ag. So rho t is 0.01 and 400 square. So we get 1600 millimeter square. Then we can take for 25 amperes for 425 amperes, so we can go to the table and look for 25 ampere area. If you go to that table, so we see that 25 m and the area is 500 millimeter square. 25 ampere, 500 millimeter square. So you go to that. So total still area is 4 multiply 500, so it's 2000 millimeter square, which is greater than 1600. So it's okay. And now since we are using this is the actual, so then our still ratio will be changed again. So our still ratio will be AST by AG. So AST will be 2000 and AG is 400 square. So then we'll get it 0.012 equals to 1.2%, which is more than 1% limit. So it's okay. Now we can also check it from the using as concrete software. We can draw the interaction diagram P by M, and before that we can also, like, P is given as 1500 kilonewton and E is 100 millimeter. So you can calculate the moment. So moment is P multiply PF, all of them are F. Force P multiply PF multiply E, so it's 1500 multiply 0.1 meter, so 150 kilonewton meter. So we can draw the interaction diagram in S concrete. So using S concrete software, and we can get the point something like that. It's like 150, and this is P equals to 1500, and this is, since this our point lies in the middle of the curve, so then it's okay since it is in the inside, so it's okay and safe, okay, safe, whatever. So it's, then that means our point is loading is safe enough and the column design is safe. So now we need to check all these design parameters. I'll see which ones we are checking. See this page. So then we need to check all of these parameters for bar spacing and longitudinal bar spacing and tie size and tie bar spacing. So we now need to check all of them. So first we are checking all these three parameters. 1.4 dB equals to 1.4 multiply 25.5 bar diameter. It's 25 amber diameter. So I'm using the actual real diameter, not 25. So then we get approximately 35 millimeter, and 1.4 multiply maximum aggregate size. So 1.4 multiply 20, which is 28 millimeter, and then also 30 millimeter minimum. So we can take this. So the max is 35 millimeter. So it's definitely more than that, but then we can still check it. So then if we use 10 tie bar, so then bar spacing, and for that tie bar is 11.3 millimeter. So then bar spacing long longitudinal bar spacing equals to B minus 2 into cover plus 2 into tie diameter plus 2 into bar diameter. So this is the dimension of the column, 400 minus 2 into cover is given, which is 40 millimeter, plus 2 into 11.3 bar diameter, and plus 2 into dB, which is 25.5. We get this here. So then we're getting it as a 250 millimeter. It's greater than 35 millimeter source. Okay. So you should do another couple of small checks. So tie bar. So we are using 10 bar, 10 tie. So then diameter of 10 is 11.3 millimeter. So which needs to be more than 0.3 dB. So what is 0.3 dB? 0.3 dB is 0.3 multiply 25.5, which is approximately 7.5 millimeter, which is 11.5 is greater than 7.5. So it's okay. So we should do one last check, and then we need to draw the column design. So we should also check tie spacing. For tie spacing, we need to check with 16 multiply dB, which is 16 multiply 25.2, approximately 400 millimeters, and then 48 multiply d tie, which is 48 multiply 11.3. What I'm doing, 11.3, which is approximately 480 millimeter, and also column dimension, which is 400 millimeters. So we need to take the minimum. Minimum is 400 millimeters. So then we should use 10 tie at 400 millimeter spacing. Now we need to do one last thing, that is the sketching the column design. What is that? So now we're doing the column design, sketch column design. So without a sketch, this all the design is useless, because you need to draw that diagram. Without drawing it, of course you need to draw it in a proper way, not like little bit curved like me. So you need to draw in straight lines. So you need to, so you saw that 425 m bar is sufficient longitudinal bars. So you can just put 4 bars in 4 corners, and you can put a 135-degree hook. So and before that, this is 400 millimeter, this is 400 millimeter, and longitudinal bar is 425 m bars, and the tie is 10 m ties at 400 millimeter spacing. And one last thing is a 135-degree hook, that is this hook, 135-degree hook. So this is the column sketch of the column design. Without the sketch, the design will be incomplete. So this is a column rectangular, short rectangular tight column design. So hopefully you guys understood. I will just make one more slide. So just make one more slide for different problems. I'll just write column design. For your exam, you should practice these different problems. Different problem sets. So first of all, you need to design rectangular or square size tight column. And what does that mean? That means size, longitudinal bar, dia, and number of bars, and tie, dia plus spacing. So you need to do that, and also you need to design and also draw interaction diagram manually, not using software. Draw interaction diagram. And the second problem is design circular spiral column, and same like full design, size plus long bar plus tie bar, and also interaction diagram. Draw interaction diagram. And of course you need to learn the software as concrete. Other thing is learn the as concrete software. But for your exam purpose, you need to practice all the problems with design rectangular or square tight column with all different steel bar, longitudinal bar, and tie bar, and draw interaction diagram, and also design a spiral column, circular spiral column, and all this steel bar and size, and draw interaction diagram. Okay, so I'm the end of class today. Thanks.